So this is just a few things coming out of chapter 2 that I know people have asked about or caused a little bit of confusion. Talking about the distribution of data and the shapes. There should be an A. All right, so the first shape is your normal distribution. It's bell shaped and it's symmetric. All right, and this is the one you most definitely want to hold on to. This is the shape and the distribution that will continually show up and as we progress throughout the course. So your bell-shaped distribution, your normal distribution is the one you most definitely want to remember.
Is that a definition of the bell shape? I mean the normal distribution.
Well, that's what it's called, normal distribution.
Okay.
And we're going to get into the details about it later. I'm just introducing it to you. Just so you'll see this section will only talk, light about it. We're actually going to get into detail when we start getting into chapter 3 about that shape and that distribution. Let me see if I can draw that better. And going back to that normal distribution, how can I explain it? So the bulk of your distribution is here. And as you move away from the middle, the least amount of your distribution occurs. And then this bulk of distribution will be where your average lies. So like I said, we'll talk more about that in detail. The only reason I bring that up here with uniform distribution, everything's being distributed at the same level. So you're talking about the same level of distribution, the same amount of distribution. All right. And the reason why I bring up these distributions is because of the next two. I want to make sure I'm clear, or we're clear on what they mean.
Is that what it's called, sir? Tail?
Nope. I'm just writing notes.
Okay.
Mm-hmm. Okay, so it's actually called or said that your distribution is skewed left. Whenever the tail of your data is to the left, notice that the bulk of your data is over here further to the right, the bulk of the data, and your tail is to the left. The only reason I go through that is because a lot of times when you think about something being skewed left, you think about being pushed left. So to me, it seems like the bulk of the data would be to the left, like because you're skewing it left or you're pushing it left, but actually it's the opposite. So the tail of the data is to the left. That's what it means to be skewed left. Okay. And then to be skewed right, that means the tail of your data is to the right. Trying to draw this stuff the best I can. All right, tried to draw those the best I could on this thing, but yeah. So when your tail is to the right, it is skewed right. Your data is considered to be skewed right. All right, questions before we go to the next one, next thing.
Nope.
All right. Stem leaf plot. I said it. So another one that people have had questions on is the stem leaf plot. So your leaf is going to be the rightmost digit of a data value, and your stem will be all of the values that precede the rightmost digit. So that means if I had the number 53, the leaf would be 3, and the stem would be 5. Well, if I had 127, the leaf would be 7 and 12. The 1, 2 before the 7 would be your stem. All right, questions on the setup or anything I've said before we actually try this out?
Nope.
Scroll up a little. All right, so here we have a data set, 41, and they have no relevance, no meaning. I just threw out some numbers. So if we had the data set of 41, 50, 56, 71, 72, 72, 75, 80, 80, 82, 83, 84, 88, 88, 89, 91, 92, 93, 100, 101, 101, 112. And we wanted to create a stem leaf plot for these data values. I'm gonna take you, make sure I didn't miss anything. Hold on, guys. Okay, cool. So first thing we would do is start off. Now I have these in order. Your data set may not be in order. It doesn't necessarily have to be, but you do need to find. Hold on one second. Let me stop this share and bring it back because this thing keep coming up. All right, there we go. So you want to establish what is your max value and what's your minimum value. So this data set goes from the 40s to the 110s. All right. Minimum value is 41, maximum value is 112. Once again, you don't necessarily have to put your data set in order, but you do need to establish what is your minimum and what is your maximum so you know how to set up your stem leaf plot. So we're going to start with the 40s and we're going to stop at the 110s. So on my stems, I'm going 40s, 50s, 60s, 70s, 80s, 90s, 100s, 20s. All right, any problems so far? Make sure we're all right.
No.
All right. So now each data value that you see needs to be represented under each stem. So notice our first value is 41. So we'll put a 1 for your leaf beside the 4. There are no more 4 values, so we go 50s. We have 50 and 56. So that'll be 0 and 6. So that represents 50, 56. Now, there are no 60s. So I don't put anything for the 60s. I cannot put a 0 because that 0 will represent the number 60. So you would just leave it blank. Then you go to your 70s, 71, 2, 2, 5. 71, 2, 2, and 5. Got 80, 80, 82, 83. And then we have 84, 88, 88, 89. So if there's a data value that is repeated, then that number needs to be wrote however many times that is repeated. Then for my 90s, 1, 2, 3. I have 100, 101, 101, and then the last one is 112. So that's just a 2. And that's how you would do the stem leaf plot.
Easy peasy.
Sounds good to me. So, so when it comes to a data set like this or a graph like this, you may ask yourself, why would you use this versus using a bar graph? You know, you could look at this as another form of a bar graph, histogram. So it's all about appealing to your audience. When it comes to statistics, I know you heard the statement that numbers never lie, but the other part of that is that they can mislead. So numbers never lie, but they can mislead. And you can take statistics, and really I look at statistics as the art of misleading with numbers, because you can take statistics, say one thing to boost your argument, or use those same numbers to say something totally different if you know how to play with the numbers. Just like in this example, if you're trying to appeal to your audience, numbers, if you have you do research on your audience, if they're number people, then you may use something like this. If they're people who like colors, and let's say you're speaking to a artsy type group or kids or something like that, then you would probably use pictures and colorful bars and stuff, So whatever appeals to your audience to keep them engaged, and whatever appeals to your audience to possibly get them on your side, is what you would use to help boost your argument. The reason why I don't get too high or low when it comes to statistics, you're talking about this political party said this and this political party said that. You can actually take the same numbers and say the exact same thing or the exact opposite thing. And they don't, no one ever goes back and check behind these stats or statistics, because that'll be too much work, right? So you can say anything you want to say, and nobody's really going to go deep into what you're saying as long as you have some percentages. Just like we'll learn once we get into outliers, you should come across what an outlier is. And an outlier is a very extreme value in comparison to your data set. So it could be very, very large or very, very small. When we get there and start talking about examining your data set with outliers, they'll tell you to run your data set or run the whatever it is you're trying to run with your outliers involved. See if it helps your argument. If that doesn't work, then take the outliers out and run it and see if that one works better for your argument. Well, so what will happen is if you were to go before your audience and you run a data set with the outliers, and somebody say, looking at your data set, and they say, hey, what about these values over here? Aren't they outliers? And you would say, yes, but they were observations. And so that's your reason for using them. But if you don't use them and someone calls you out on it and say, hey, what about these numbers over here? Why didn't you use those? You could say, well, hey, they were outliers. That's not the normal, range of data set. So people can use numbers to manipulate very easily. So keep that in mind as we go throughout statistics, why we do certain things. It's all about what are you trying to do with these numbers? Are you trying to boost your argument? And what would help you boost your argument the best? Let me look in this book, make sure it wasn't anything else I was supposed to say today before we look to close out. Any questions before I do so?
Sir,
Yes.
then the right numbers are the outliers. What are the left numbers?
No. I was using outliers as an example. I was just talking about outliers. None of these are outliers. So I was just saying outliers are very extreme values in comparison to your data set. I was just talking in general, just giving
Okay.
you my, yeah. So these are, all of these are fine. 75.5. Okay, well, I think that is it as far as just making sure you're clear on a few things. Try the stuff out in my math lab, chapter 1 and chapter 2. There are some graphs in there. Trust me, it would be in your best interest and mine if I don't try to draw these graphs for you. It'd be better if you were to email me and say, I had a question on this graph and I can go to it in my math lab and stuff like that. Most of them are self-explanatory, bar graphs, pie graphs, and all the good stuff like that. Yeah, so with that being said, any other questions before we close out for the weekend? Make sure we're good.
Just don't forget to post those definitions.
What
I'm trying to
definitions?
get my homework done before the weekend.
What definitions you talking about?
Look, I'm the senile one here. Stop it. Just
I
look
will get right on that.
All right, thank you.
All right, no problem. Outside of that, you guys have a great weekend and be safe.
Thank you, sir. You
Thank
too.
you. See you
No
guys
lab next Thursday, right? No
Say that one more
class.
time.
No class next Thursday.
Why? What's happening next Thursday?
Said next Thursday we didn't have class.
See, there you go. There you go.
Okay, for all the people in the classroom, I need y'all to come in with me. Didn't he say that?
No, we are having class Tuesday and Thursday as usual.
Could have sworn Tuesday you said not this Thursday, but the following Thursday, no class.
No, I don't remember that. I don't remember saying that.
That's what homeworks do.
Yeah, that's when homeworks do. Yeah. Chapter 1, chapter 2's definitions are due on next Thursday.
Okay, I'm going to take some medicine. Thank you.
All right. Y'all have a good one.